Hello, my name is Ethan Witwer, and I will be presenting, as Aaron said, Dodge, framework for defending against video fingerprinting at the client side. And I developed this with the help of David Hasselquist and my two advisors, Tobias and Niklas. To get started, the threat model is basically the same as the last two presentations. Video traffic is encrypted, but it still leaks what you're watching. So a passive observer on your network path, such as another user on the same network, a network administrator, or your internet service provider, just watches your traffic. And since Dash, the most widely used protocol for on-demand video streaming, sends videos in segments, the sizes and timing of the encrypted segments form a pattern that serves as a very identifiable fingerprint for each video. And the attacks turn out to be very successful even if you have a VPN or Tor. The pattern is still discernible and can be used to identify what you're watching. And at a technical level, there's more to it than just the segments, but basically this is what we're dealing with as the issue. So one way to defend against video fingerprinting would be to implement a specific defense, but that's fragile because if you have one specific defense, it could be defeated by new attacks, which would require re-implementation, or it could mean that you may want to have different defenses depending on your use case and you're locked into one defense. So the idea with Dodge is to have a framework where an in-player framework where defenses are just files. So we have a file format which is based on JSON called extended manifests, and those use a building block called cycles, which I'll discuss shortly. But the idea is you have an in-player framework, and to use the defense, you just have to pass the URL of a file to the player, a JSON file. So the model that Dodge uses is really quite simple. Cycles are just a generalization of video segment downloads. So you can have full segment downloads, you can have partial segment downloads, which are later reassembled by the player before being buffered. And you can have padding, which is just downloaded and discarded immediately. And extended manifests specify the cycles to download for a video, which segment index should be downloaded at each cycle, the byte range, when all pending data should be sent to the buffer, which controls timing of segment downloads or cycle downloads and reassembly of partial segments, and which cycles are padding. And all of this is done on the client side. So to test the capabilities of the framework, we built a proof of concept defense called Dodge Mimic, which is based on k-anonymity, which makes videos in a chosen set look identical to minimize the cost function. And the reason for using k-anonymity is not that it's a perfect defense to use in practice, it's because it gives theoretical bounds that we can verify against classifier-based attackers. So that's the proof of concept defense that we made to test the framework. It also allowed us to have a specific traffic pattern that we wanted to create using these extended manifests. And so we use a live algorithm where you can adjust K to control the trade-off between bandwidth, overhead, and protection. And if you let the algorithm run longer, it'll generate better sets. And we use a cost function based on bandwidth overhead, meaning if you let the algorithm run longer, you will get lower overhead sets. So we tested this proof of concept defense using two directly connected machines, a client and video server, with a data set of 1,400 videos, and the results show that Dodge removes all of the leakage that can feasibly be removed. So the attacker accuracy is pretty close to the theoretical bounds of k-anonymity. It is a few percentage points higher in the worst case, though, and that is due to intra-segment timing, which can't be controlled at the application layer. But we expect that to be less exploitable in practice than in our tightly controlled experiments. And some other things about Dodge Mimic, we see that it has moderate bandwidth overhead, typically between 20 and 75%. And quality of experience does not really degrade at all. It's similar to undefended traffic on a number of metrics, and essentially you have a slightly longer startup delay in the worst case. But what I consider to be the biggest impact of our work on Dodge is its deployability. Dodge is implemented as a module for the Dash.js video player, which is the reference player for the Dash video streaming standard. And to deploy it, you just need to swap out one JavaScript file and add another one containing the Dodge module. Dash.js is already used by a number of content providers, and extended manifests can be hosted anywhere, such as on the video server alongside videos on another server, or locally if you have your own setup of Dodge. And to make it even easier to deploy Dodge, it's currently in the process of being merged into the official Dash.js player as part of the next minor version. So the expected date for that is sometime in August, but no promises about the exact timing. And we're also currently working on a browser extension, which we'll be releasing in the coming days, which will allow you to use Dodge in a number of different ways. And the goal of that is to have something that can be used by ordinary users pretty quickly. So that Dodge will be a part of Dash.js, which content providers can opt into. Pretty easy to deploy on your website, and there will be a browser extension that anybody should be able to use. And that brings us to the takeaways, which are basically that video fingerprinting is a relatively easy and effective attack, which is why defenses are necessary. I think that a framework is a better idea than having a hard-coded defense because of continually improving attacks and the burden of re-implementation, plus the added benefit of being able to pick defenses based on your use case. And we address that with Dodge, which we've shown works via our experiments with the proof of concept defense, Dodge Mimic, and which is deployable and soon to be officially in Dash.js. So thanks for listening, and I'll be happy to take any questions at the poster.